Alright, so let's have a look at another question. This one comes from ordinary differential equations. So this time we're going to be having a look at another third order differential equation. So this one is y prime 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 plus y prime equals 0. And we do have initial conditions here. We are told y of 0 is equal to 0. We are told y prime of 0 is equal to 1. And we are told y double prime of 0 is equal to 2. So this is a third order differential equation. This is a really interesting type of differential equation. These differential equations, sometimes you see them and they look very short. And when you see a very short differential equation, you think, oh, easy, right? No, it's very possible that it's not easy. And it's very possible that this is going to work in a slightly frustrating way. So we need to be very careful with that. So we're going to start by drawing our characteristic polynomial. So y, let me pick a new color, let me pick ice blue. Y prime 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 plus 0 y double prime plus y prime plus 0 y is equal to 0. Well, this reduces to the characteristic polynomial r cubed plus r is equal to 0. If I factor this, I can take r at the front and I get r squared plus 1 is equal to 0. If I solve this, this means r is either 0 or r is the square root of negative 1. So this is r is the plus minus square root of minus 1. This is plus minus I. So here we have a single real valued root, and then we have two complex roots, one which is plus I and one which is minus I. So if we have real roots, as we've seen many times as we've gone through these equations, we will have a particular type of solution. So the particular type of solution for a real root is something like a times e to the rx. So this is the solution for a real root. This root is 0. So this is actually just going to reduce to a. It's just a constant solution. So this equation, one of the solutions will be a constant solution. And then if we have a pair of complex conjugates, those solutions, this will yield us two solutions, which will be a e to the alpha x times cosine of beta x plus b e to the alpha x times sine of beta x. And here we know we're looking at this as if the complex number was written in the form alpha plus I beta. So this has to be in the form of alpha plus I times beta. So in this case, alpha is 0 and beta is actually 1. So alpha is 0, beta is 1. This is plus minus. Beta is 1. So this will reduce to the alpha of 0 cancels the e terms. This gives us a cosine of x plus b sine of x. Now, because all three of these are solutions, we can't use the coefficient a twice. So our general solution will be the sum of these. Y of x will be equal to a constant a plus b times cosine of x plus c times sine of x. And this is our general solution to this third order differential equation. Now we need to find values for a, b and c using the initial conditions we've been given with the question. So this is the y of 0 is 0, y prime of 0 is 1, y double prime of 0 is 2. So we need to find the first derivative and the second derivative. So our first derivative, y prime of x, is equal to, well, the a goes away, b times cosine of x. Cosine differentiates to minus sine. So this is minus b sine of x. Sine differentiates to cosine. So this is plus c cosine of x. And then our second derivative, y double prime of x, is equal to, well, minus sine becomes minus cosine, minus b cosine of x, minus cosine becomes minus sine, minus c cosine of x. And now we need to evaluate these under the three given initial conditions. So we are going to get as our first equation, y of 0 is equal to 0. This is equal to a plus b times cosine of 0 plus c times sine of 0. Now cosine of 0 we know is 1, sine of 0 we know is 0. So this reduces to 0 is equal to a plus b. So this means a is minus b. So this is our first little equation linking a and b. Now we're going to use the first derivative. Y prime of 0 is 1, so this means 1 is equal to minus b times sine of 0 plus c times cosine of 0. Now we know sine of 0 is 0, so this whole term goes away. Cosine of 0 is 1. And this actually tells us that c is equal to 1. Now if we use our second derivative, y double prime of 0 is 2. This gives us 2 is equal to minus b times cosine of 0. Cosine of 0 minus c times, let me fix this up. This should be sine up here. Positive cosine became negative sine. Times c times sine of 0. Now again, c sine of 0 is 0. So cosine of 0 is 1. And this tells us that 2 is equal to minus b. And this means b is minus 2. So c is 1, b is minus 2. We were told up here that a plus b is 0. This implies that a must be equal to 2. So we've now found a, b, c coefficients, which are going to make this general solution a specific solution for these initial conditions. So a plus b cos x plus c sin x. So this means our specific solution, spec, is going to be y of x is equal to 2 plus minus 2 cosine of x plus 1 times sine of x. So let me just confirm this is correct, plus sine of x, yep. So this is now our specific solution. And as we've done every time so far, we are going to take this specific solution, take its first derivative, take its second derivative, take its third derivative, plug the third derivative and the first derivative into the equation we've been given to check. So we now need to check that this actually works. So y prime of x is equal to minus cosine. Minus cosine will become plus sine. So this will be 2 sine of x. Sine x becomes cosine x plus cosine x. The second derivative, y double prime of x, will become, well, sine will become cosine. So this will be 2 cosine of x. Cosine will become minus sine of x. And then y triple prime of x will be equal to, cosine will become minus sine, so this will become minus 2 sine of x, minus sine becomes minus cosine of x. And then we're going to plug y triple prime and y prime in and hope that these cancel. So we have y prime 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 plus y prime equals 0. This implies the y triple prime, which we just found is minus 2 sine of x, minus cosine of x plus y prime, which is 2 sine of x plus cosine of x, is apparently equal to 0. Cosines cancel, sines cancel. This gives us 0 equals 0, 0 equals 0, and this is true. Right? So we've been able to successfully check and confirm that the specific solution that we calculated over here on the right is in fact the specific solution to this third order differential equation.